Okay, let's look at question 3. So a vector A and B are such that A dot B is -1. And also given that A cross B plus A is perpendicular to this guy here, show that modulus A cross B equals 1. I think this is pretty okay. We're just going to use the information given to us. This is perpendicular to this, so we know the dot product is 0, right? So we're just going to write this down. Firstly, A cross B plus A dot with A cross B plus B is equals to 0. Okay, because they are perpendicular to each other. So what we need to do next is just understand that this and this is these two vectors are the same. You see this and you can see this as a vector C, okay? So they are actually just one vector. So when you distribute it, you cross it, like dot it in. This will be A cross B dot with A cross B. Okay, over here. Then similarly, this over here, just go over there. This will be A cross B dot with B plus A dot A cross B, okay, plus A dot B equals to 0. Great. So this is important. Firstly, the first guy here, these two vectors, any vector dot by itself would just be the modulus of itself square. Okay, so remember, C dot C is equal to mod C square, right? So simplistically speaking, it's like that. So if you have got A cross B dot with A cross B, so this would then be mod A cross B square. Okay, so using the same dot product result, the scalar product. Then after which this over here, just understand that when we have got A cross B dot B, this will be 0. Okay, because essentially what does this mean is that A cross B is a normal. Okay, let's say if we have a plane, this is A and this is B, right? Okay, so maybe here use the other way around. So this is A and this is B. So this would be A cross B. Okay. Now the thing about A cross B is actually A cross B is perpendicular to both A and B. Okay. So meaning to say when you cross is a normal, right? So essentially, since this is perpendicular, so you can be sure that this guy here is 0, the dot product is 0, this as well is 0. Okay, so that's the important part. Okay, so these two are 0 vector. So it's not 0 vector, sorry, this is scalar product of 0. Then this will be mod A square. So this is mod A squared plus 0 plus 0. Then we're given that A dot B is -1. So this will be -1 over here equals to 0. So hence mod A cross B square is equals to 1. Shown. Okay, so there's that. So I need to just understand this part here. Then let's look at B. Now B, find the angle between direction A and the direction B. Okay, so this is important. Hence, right? Now why? Now when A dot B, okay, we firstly understand this. When A dot B is negative, we know that if it's negative, we know that the angle is obtuse. Because when you talk about the angle between two vectors, is either acute or obtuse. So ASTC, right? A dot B is actually mod A mod B cosine theta. Okay, this when it's negative, what happens is that you know ASTC, right? ASTC. When cosine is negative in the second quadrant, so this is the only thing that which will be responsible for it being negative. Okay, so just be mindful of that. Whereas for sine, you can't really tell, but from sine, because A cross B is mod A cross B is mod A mod B sine theta, right? But the sine theta, you can't really tell whether it's the first or second quadrant. Okay, so that it doesn't show you that. So we just write that two things down. Oh, so this is 1. This is square, so I haven't finished this. So this will just be mod A cross B equals to 1. 0. Okay, great. So I'm going to write the two results down. So write down these two results. So A cross B, using cross product A cross B cross C sine theta equals to 1. Okay, this will then be A mod B cosine theta given by -1. So 1 and 2, we just do long division. Just 1 divided by 2. That will be sine theta. Okay, so it's quite okay, right? You will cancel the mod A, mod B. You don't really need to know what is mod A, mod B in this sense. So cosine theta equals to 1 over minus 1. So this case here, this will be tangent theta equals to minus 1. So this case here, you know that for tangent to be negative, it will be ASTC. Is either the second quadrant or the fourth quadrant, right? So you know that basic angle alpha, this is 45 degrees, right? Or you work out in radian is pi over 4. So it's actually this like angle between two vectors has to be either acute or obtuse. So it has to be the second quadrant. So hence theta will just be in Q2, which is 180 minus 45. Okay, or pi minus pi over 4. So either one is fine. So here you'll get 135 degrees or 3/4 pi. Okay, so that's how you do this question 3 here.